Okay. Okay, so today we are going to talk about implant prosthodontics. So let's make it into a structured lecture. Basically, the implant prosthodontics, there are many components. We start with single implant. So imagine we have a situation where we have placed one single implant in region of 4-6. Let's consider any implant. So any implant will have certain kind of impression posts, formers, abutments for making that particular crown. So first what we have to keep in mind is what is the interarch distance for that particular restoration which we are going to do, that prosthesis. Okay, so if we are having a good interarch space, we can, if we are having good interarch space, which means between 7 to 11 mm, we can go for 8 to 11 mm, we can go for cement retained also, we can go for screw retained also. But if we are having less than 7 mm, then we should opt for screw retained only, because the height of the abutment becomes very small and the crown can dislodge very easily. If we are having more than 12 mm of interarch space, then screw retained crowns, true screw retained crowns, will create a vertical cantilever problem. The crown root ratio, it's not known as crown root ratio in implant terms, it is known as vertical cantilever. That will create lot of stresses on the screw, and the screw or the hex can damage in long run due to lateral forces. So there we prefer a cement retained crown. Okay, now what are the various abutments which are available to us for a single tooth? Let us understand that. So for a single tooth, we assume that we are going to work on the implant level area. Implant level is what? Inside the implant. So our crown, our abutment, our suprastructure is directly going to go and insert inside the abutment in the implant. In the implant there will be either hex connection, internal hex, or there will be conical connection, or there will be deep internal hex like in Korean systems. There will be shallow internal hex like in Israeli systems, Norris, Aidin, Bioline, all come with internal hex which is shallow. Quick dent also. All of these systems, even MIS comes with internal hex. All of these systems will have similar components, but it is always better to use the final abutment and the scan body of the company itself, never third party. Things like former can be used, or impression post for jig trial for up to an extent can be used interchangeably within the systems. But if you are having an MSDI implant, an Aidin implant, a Bioline implant, a Norris implant, a MIS implant, any kind of implant, the final abutment should be of that company, sourced from the company only. It should not be the third party. Okay, now the scan bodies can be third party, the analogs can be third party because we can save cost in that. The formers can be third party, it doesn't matter. Now what do we have for when we are recording a physical impression for a single implant? We have a physical impression post for a single implant. In physical impression post, we can have closed tray impression post, open tray impression post. Okay, so closed tray impression post will always have a rounded edge, a rounded end, so that when the impression is taken, the impression post can be removed from the mouth and can be inserted inside in the impression itself. So it will be like this. So like how this is, I am holding one impression post. This is like an impression post. We can see, na?
Yes.
So this is having very clear indentations, so that when the impression is taken out, these indentations are recorded in the impression, and when we take out the impression post from the mouth, we attach the lab analog, we turn it upside down, and we can position it exactly how it was in the mouth in the impression. But this is not the best technique or best thing to do, because while removal of the impression post and then inserting into the impression can cause some micro movement that can get transferred into the implant abutment interface, and that's why where we can have little problems in the jig trial where fitting errors can be. So it is better to pick up the impression post with the impression itself, so that this transfer error doesn't occur. More number of steps will lead to more errors. So we have a option of doing open tray impression. An open tray impression now basically has like a indentation or a groove or a holding area in the impression post itself, where the impression material will go and lock into it. Okay, so these impression posts are to be opened from top as a open tray. We cut out the tray, we open it from the hex, and then we take the impression out along with this impression post. Make sure that we open it fully, we remove this screw, and then we take out the tray from the mouth. Otherwise, sometimes even if one thread is locked, then it can create lot of pressure on the implant can break, or implant can also come out. Okay, or the tray can get really locked inside. Now open tray impressions are preferred even for single teeth, but we have to remember single implant impressions are always to be done with hexed impression posts. Any kind of work which we are doing in single implant has to be done with hexed impression post. Okay, it can be hexed impression post, it will be a hexed abutment. Okay, so hexed impression post means that the lower surface where the implant will attach to the abutment will contain a hex like this. Okay, now if we have two adjacent implants with each other, only then we are supposed to use a non-hexed impression post if we are doing a impression. Non-hexed means the lower portion of the impression post will have a very smooth circular surface. Okay, it will have a very smooth circular surface. It will not have a hex like our abutment has. It will not have a hex which goes into the hex of the implant. Implant will always have a hex. Lab analog will always have a hex, whether it is single or multiple. But impression post and abutments can be hexed or can be non-hexed. Scan bodies will always have a hex. Implant level scan bodies always have a hex. Okay, so this is a circular. Why this is? Because slight amount of discrepancies will occur when we are doing multiple implants, when we are taking impression and taking it out. So we need a little play or a little discrepancy between the hex of the implant and the abutments, so that passive fit can be achieved. If there is some area where the hex is going into the hex tightly, or cone is going into the cone tightly, and it is getting locked, then the impressions and scans have to be 100% accurate, otherwise it will never fit in. It's an engineering principle. So we cannot never have everything 100, we'll have 99.9% accuracy. So to prevent that 0.1% misfit or angulation error, we can always have one portion hex and one portion non-hex. So hex will always be, implant will always have a hex or a anti-rotation feature, but this impression post will not have any anti-rotation feature, or the hex will not be present. Okay, now single implant, we talk about prosthetic options. Prosthetic options, if we are doing physical impressions, the first prosthetic option which we have is a stock abutment. Stock abutment is something which is available with the implant company. The implant and abutment which we order many times, implant plus abutment, so that is a complete prosthetic solution which they give us. So yeah, so this is how one implant abutment looks like. This is a stock abutment, very simple stock abutment. This is a straight abutment. In implant, when we can order from the company, we can get straight also, we can get angulated also. If we have placed the implant slightly angulated, we can start the angulations from 15 degrees in some cases we get up to 25 degrees, and some cases we get maximum up to 30 degrees for a single case. Okay, it is not recommended to go beyond 30 degrees in a single implant case, because there will be too many lateral forces on the implant and it can fracture. Okay, so stock abutments, very good thing, because they are manufactured in the same company where the implant is manufactured. So the company which is supplying us the implant will make sure that the parts will fit perfectly with each other. So it is really good, but there is no customization. So if we are doing it, what we had taken example was 4/6. So if we are doing 4/6, then for a molar site, this abutment is very narrow, it's very small. We need a wider base of the abutment, so that the forces of buccal, lingual, mesial, distal, they are spread evenly on the abutment. They are going to be transferred to the implant, and from the implant to the crestal bone and down up to 7 mm inside. But when we don't have a wider platform, the emergence profile will be compromised. So to get a good emergence profile of the case, we need to use custom abutments, or we need to customize the abutment in some way. Now stock abutments usually don't give us the option of having very wider base as the abutment. It doesn't have a lot of collar heights, maximum up to 4 mm we can have collar height. So if your implant is deeper than 4 mm, you have to customize it. There is the no way. If your implant is more angulated than 25 degrees, you have to customize it. But up to 4 mm and up to 25 degrees, we can use the stock abutment. Okay. Now when we are using the stock abutment, that particular crown will never be a true screw retained crown. Okay, it will always be a screw cement retained crown. So if you are doing a 4/6 and if you are using this abutment, what the lab will do, you will give them the impression with the analog. They will pour that. They will put the abutment on the cast. Then they will start building the crown from the abutment level. Then when you tell them you fix the crown on the abutment and give me, what they will do, they will use Relix U200. They will first use a zirconia primer, coat the abutment, metal bonding ho jayega. Then they will use zirconia primer or metal primer on the crown, whichever you have selected. They will bond it with Relix U200, which is a universal luting cement. They will seat it on the crown and then they will give. What we feel is the crown and abutment is one portion, so it's a screw retained crown. But actually it is a cement retained with axis hole crown. Okay. On stock abutment, we can never have screw retained, true screw retained crown. True screw retained crowns always need customized abutments, either with casting technology or with DMLS technology, or there is one more technology now which is known as tie base or CAD CAM abutment technology. Okay. Okay. So single implant mein we have covered till stock abutment. Next is customization. So how do we customize the abutment? We can have castable abutments which come in red or white color. They will be casted according to the burnout wax technique. So in those we have two kinds of abutments. We have abutments which are having the hex portion also castable, or we have abutments where hex portion is from the company but the top sleeve is castable. Okay, so we always prefer that the hex portion should be from the company, because something is going inside the implant. We don't want any casting shrinkage or any issues with that. If in case nowadays we don't use casting technology, but if in case we are using casting technology, always try to order for abutments which have hex from the stock from the company, but the only upper sleeve is customizable completely. Those kind of abutments are known as UCLA abutment, because they were derived in University of North Carolina, and that's why it is known as UCLA abutment. Those abutments have a white sleeve and internally inside they have a so this is like the sleeve. This is the sleeve. This is a titanium base plastic or a castable sleeve of the abutment. Okay, so this particular hex portion will be from the stock, and sleeve will be burnout. So once the burnout is done, we will do a wax pattern. So how this workflow will go? The lab will put this abutment with the stock hex in the implant. They will attach the white color or red color sleeve on top of it. They will build the whole crown. Like if we are doing a PFM, they'll build a PFM. They'll build a wax pattern. Then they will remove that particular the abutment. They will put it into firing. Do the whole casting process. The hex portion will be from the company. The top portion will be from the lab, customized, and then they will put ceramic on top of it. Yeah, something like this. So this is like a plastic on top, and the hex is from the company. Okay. So this is preferred if you are doing castable. Now we go to next. Next is DMLS abutment, which is direct metal laser sintering. With this technology, we cannot have stock hex of the implant company. We cannot have the whole from the hex portion to the final prosthesis. Everything is made in the lab. but it is fitting is better than the castable. There is less shrinkage. It is made in cobalt chromium powder. Okay, so that it is printed. It can also be made in titanium. It can be, cobalt chromium is a little stiffer, so that can be made from the hex up. So here, this is also a good method for making single or multiple implants. The next part is CAD-CAM abutment. Now CAD-CAM abutment is known as tie base. Okay, let's cover milled abutment. Milled abutment. So milled abutment is, we have a certain kind of block of titanium like this. The top portion is a huge bulk of titanium. The bottom portion is a hex. What we do is we put this into the CAD-CAM milling machine. Then the machine will digitally design the abutment as our requirement. So flower shape or tulip shape, emergence profile, how much thickness of collar height, how much is to be done, how much is the abutment collar or shaft to be done. All this can be made. So this is one example of a milled abutment, titanium milled abutment from this. So this was the actual product. This is how we get it from the company. So I have ordered lot of implant abutments. जैसे order करते हैं ना, package लेते हैं ना, implant plus abutment का package. I always tell them give me pre-mill or give me tie base, because that's how we want to work. We don't want to do casting, DMLS भी avoid कर देना. So we do this. For single implants, cement retained, if we can do, this is the best. Okay, or tie base is the best. So this is how we will get one abutment. We can mill it. We have milled it from this. Okay, so this is really good customization, because the hex part is already made by the company. Only the top portion we are milling, which generates less heat, does not do casting shrinkage, does not have any fitting issues. And for single cases where we can do cement retained, we want a customized solution. This is really, really good. Okay, so next portion is the tie base. Now let's talk about tie base. So everything what we told right now before this part was on implant level. We had taken implant level impression and everything was occurring on implant level. Now impression for tie base also will be implant level, but when we are doing the designing of the crown, in the ExoCAD file, when we have taken a scan, this can only work when we have scans or when we are doing the digital workflow tie base. The scan recognizes the short abutment portion also. So now when our zirconia crown is getting made, now only zirconia and PFM can be made. PFM also, that also milled or DMLS. It cannot make casted crowns. We cannot make casted crowns on tie base. When we are making that tie base, when we send the tie base to the lab, what they do, they will identify the code of this tie base. They will tell the software, I have the implant in this portion because we have recorded it on the scan body. I have the tie base also. The tie base also is merged. From the tie base up, the zirconia crown is now made. It is not made from the implant level. Crown is made from the abutment level in tie base workflow, and then the fitting of that abutment to the tie base is really, really good, because that is perfect match, and that's what they will cement and give us. They will use again the same protocol which they did for the castable part. As I told, they will have a sleeve and the sleeve will be sent for burnout, but here there is no sleeve. There is fully digitally made. It works best for zirconia than PFM. We can there is a shaft, small shaft over here, and then there is the gingival portion. So upper portion, the shaft or the stalk of the abutment, that shape is very perfectly replicated in the intaglio surface of the crown. So they will put again zirconia primer on the crown internal surface, metal primer on the external surface of this, and they will elute it with U200 on the cast, remove the excess, cure it properly, and then they will give it to us. So again, in actual screw cement retained terms, this is a cement retained with the access hole, but as the process and the workflow is completely digitized, it is much, much better. And in this we have one more advantage. When we are making customization of pre-mill or castable, the subcritical and critical zone of the emergence profile is in titanium or cobalt chromium. But in tie base, we can have that customization in zirconium, which is a much more friendlier material than titanium or cobalt chromium for the gingiva. That is why we prefer tie base. Let the zirconium go inside the implant till the implant level. Let it go as deep as possible. Let the gingiva grow over and attach to the unglazed zirconia, because it works, the hemidesmosomal attachment of the gingiva works only on unglazed zirconia. Because when we are doing this, we have to make sure that when we are doing the final fitting of the crown, or we tell the lab till the gingival level, I want the zirconia to be unglazed and only hand polished. So if the lab person has given us fully glazed zirconia everywhere, it's okay, we can ourselves remove it and polish it nicely. Then gingival attachment will be even better. Glaze layer is a very bad layer for the gingiva, and even for the opposing crown. The opposing natural tooth also gets more abraded because of the unglazed layer of glazed layer of the zirconia. So we make sure that we remove it from there. Okay, so good labs will automatically understand this subcritical critical level, and they will give us a polished surface, hand polish, rather than giving unglazed surface below the gingival margin. So from the from the implant level to the gingival margin, we have unglazed zirconia. From gingival margin to the occlusal surface, we have glazed zirconia. Got it? Now that this is the advantage. When zirconia is in contact with the gingiva, it is better. So this covers everything for single implant. This was all hexed. We have not used any non-hexed component over here. इसको pause करो.
This is the part now. So what does that look like?
So there is one more now customization. We can have abutments customized in cobalt chromium with any technology, with casting, with MLS, or with milling. We can have it in titanium with casting or milling. Titanium is only MLS and milling. We can also have customizations of the abutment in zirconium. So how we do that? When we have a very highly aesthetic case of anterior implants, let me. No, Chaya Kate is not zirconia. This is PEEK. That is bio-HPP. Okay. So we have certain materials with which we can deliver this kind of a final result to the patient. Okay. Now this result is because of using, this is an implant, this is a natural crown, this is a natural crown. Okay. Now this is because we have used. Now you can see the opacity and translucency of all these three crowns is almost similar. Okay, it is not having implant ka koi ek grayish portion is not visible. Why that is? Because here we have utilized technology of doing tie base zirconia abutment. So we have a titanium base on which we have not directly gone ahead and made the crown. We have made a abutment first, like this. See, so we have a tie base inside. On top of it, we have made a zirconia abutment. Now the zirconia abutment part internally is also zirconia, externally is also zirconia. Only the implant hex is going in, the titanium hex is going into the implant. And then on top of that, we have fixed the crown. Okay. So on top of that abutment, we have fixed this Emax crown. So Emax crown is bonded on top of the zirconia base. Yeah, ये मस्त है दिखाने के लिए. So this is the tie base. On top we have the zirconia substructure, and then the crown, which is the final suprastructure. So now substructure and suprastructure, these are two new words which we are learning. Substructure is the part which attaches to the tie base. Suprastructure is the part which attaches the crown to the substructure. This will come in full mouth implant when we understand the different workflows. There is another material to customize now, which is known as bio-HPP. Bio-HPP is again wonderful, flexible material. Modulus of elasticity of bio-HPP is more closer to the bone. That's why many people are using it in full arch frameworks also in single implant also, and also it is aesthetic looking. We can color it pink also, we can color it white also. So there also the substructure where the zirconia abutment was made, at that portion we use bio HPP. We can use PEEK also, we can use graphene also, we can use composites also. So many materials are there, but till now for anterior aesthetic cases, zirconia abutment works really well, bio HPP works really well. Zirconia is a little expensive, bio HPP is little cheaper, that's why now bio HPP is more popular. So this all covers the implant prosthodontics of single implant on hex.